Hello, student. Good afternoon. As you know that there is worldwide this coronavirus spreading. Government of India has decided to lock down the educational institution, and I know that you guys are missing the classes. So, because of that situation, so we are planning to do this online video. This is my first time I am doing the online video. Okay, and I am trying to teach you slowly, and also I will give you post those videos in my YouTube channel, so you can uh, download the videos. You can go and click and see all those videos from YouTube channel. Okay, so let us start. So today we will start a discussion on mm, properties of expectation, properties of expectation. Um, Obviously I will go to these special cases for joint distribution, but before that let us just discuss the general scenario. So what happens when suppose we have a random variable x, so let x be a random variable. Okay, and you know that uh, you know that you know that that probability that the random variable is taking values in between this quantity a and b equal to 1, the full probability, um, then the expected value should satisfy this condition. Then expected value of the random variable x should be in between a and b. So my pen is not working properly, but it's okay. I will try to read properly. So the proof is simple. So um, you can prove it separately for discrete random variable and continuous random variable. So let me assume that. So proof. So assume that uh, x is a discrete suppose that x is a discrete random variable. So in this case, what happened in this case, we know that by definition expectation expected values of x will be of this form, summation over all those x for which the probability of x is positive, x time the px, the probability mass function. Okay, and we know that x is taking values in between a to b, so this quantity is bigger than summation a times probability mass function with px positive, sum over all the x with px positive. Okay, and now we see that this quantity, the latter quantity, is nothing but a times probability of the mass function sum over x. And as we know that x is a discrete random variable, this sum over px, this sum is 1, and hence this quantity is a. And similarly you can also do it other way. So uh, this quantity is also less than equal to summation b into the mass function and sum over x. The probability, whenever the probability is non-negative, I greater than 0, and this is also b. So what does that mean? What is the conclusion? The conclusion is that if a random variable is taking values in between a and b with probability 1, then expected values must be in between a and b. So the conclusion is that the expected values in this case will always be in between a and b. Okay, so this is a general discussion. Now let us discuss some of the rules, propositions for expected values for function of joint distribution. So for example, we have learned for function of single random variables, and now we can extend our previous theory for function of joint distribution. So recall that. So just let me just recall. Recall that suppose we have one random variable x, and we want to know what is the expected values of some function of x gx. Then we know that this is, we can easily do it by this, and I hope you guys remember the proof which was discussed in the class long back ago. Okay, this is for a discrete case. For continuous case, minus infinity to infinity gx. If x is the probability density function of the random variable capital X. Continuous case. Okay, so same thing, if one can ask the similar question, what happened for function of joint distribution. So now suppose we have two random variable x and y, and you have function g of x and y, and you want to know that what will be the expected values of this. And the result is similar, you can extend from the previous result, so you can extend it easily, and the proof is also simple. So I am not writing the proof here, you can think this is an exercise. So we have joint distributions, we have double sum over y over x, and then g of x y, and p of xy. So this is the joint probability mass function of x and y. So pxy is the joint probability mass function. So this is like again for discrete case, discrete, and for continuous case, what happened? For continuous case, you have integral from minus infinity to plus infinity, again integral from minus infinity to plus infinity. Sorry, my pen is not working properly, so let us to understand what I am saying. So g of x and then the joint density function f of x y. So this is, you can either write by these or you can write by these also, so whatever you feel. Dx dy, and this is for continuous case. This is for continuous case. Okay, so now let us try to apply this thing using some application, some example. So now suppose that so example, so suppose example say 1 for today's lecture. Now suppose that there is a road, say to extreme point A and B, and the length is, so length of this road is say L, the distance from A to B is L, and suppose that there might be an accident on that road. So the accident can occur in between any points A and B, and let us assume that the accident occurred at that point say X. So X is the point where the accident occurred, and say small x is the distance from these points to the say origin point A. Okay, and this random variable capital X measures the distance from A to the point of accident, and it is uniformly distributed throughout the line segment A to B. Okay, clear? So it's clear that X is a uniform distribution, so you can say that X is uniformly distributed. Okay, and the length is what? The length is L, so over L. So what does that mean? That means you have the density function of x is defined by 1 by capital L whenever your x is in between. The x is the distance, so this distance in between, say 0 to capital L, so the whole distance. Okay, and there might be a situation that, so you have an ambulance which is also running in between these 2 points A and B. An ambulance is also at that moment ambulance is locating at some point, say these points, and suppose this distance is y, this distance is y from A to that point, and suppose capital Y denotes the distance of an ambulance, distance of an ambulance. So this is a random variable that is measuring the distance from A to the location of the ambulance. An ambulance also can be there uniformly in between A to B, capital A to B. So capital Y is also an uniform distribution parameter. L is the length of the road. So you have that density functions, the PDF probability density function of y is also zero otherwise. One by L is 0 less than y less than L and 0 otherwise. Okay, now we're assuming that that point of accident and the location of the ambulance, they are independently distributed. Suppose, so what does that mean? That means the joint density function of x and y. So the joint density will be of this form. If of 1 over L square whenever your 0 less than x less than L and 0 less than y less than L. Okay, and 0 otherwise. Suppose this is the joint density, then this is the joint density. I am assuming that x and y are independently distributed. Okay, now the question is that can you find out the expected distance from the point of accident to the location of the ambulance? So what does that mean? That means On an average, what is the distance between these 2 points where the accident occurred and where the ambulance is there at that moment? And if you know that, then we can also find out the expected time it will take to reach. And by that, we can calculate how much time it will take to that patient to take to the hospital or not. Okay, so let us try to understand this problem. So, so now you can easily understand that the distance between x and y is function of the number level xy. So you can think that it's kind of g of capital X and capital Y, which is the distance between x and y. So why this mod xy? Because so it's not the case that x is always nearer to the point A. It can be the case that y is also nearer to the point A. So this is a distance which measures where is that the distance between the location of ambulance and the location of the point of accident. Okay, so this is the function of xy, and we are interested to know that what is this expected distance. So what does that mean? That means expectation of g of x y. So this is we are interested to know. Okay, now we can apply our previous formula. So you just recall, can apply our previous formula here. So this is both x and y are continuous non-variable. So this second formula for continuous non-variable is going to apply. Okay. So now how to find out? So let us try to find out this. So we can write down by formula this expected distance is g of x y. By definition, this will be what? This is nothing but minus infinity plus infinity. But remember that the function has no value otherwise other than in between 0 and L. So you can write down 0 to L, 0 to L. Okay, and then these values mod of x minus y into the joint density function. So what is the joint density function here? It is 1 by L square. Okay, and then you have uh, dx dy. Okay, and you can also write it down as this 1 by L square, and then the inner integral 0 to L. This is the outer integral obviously, and the inner integral is 0 to L mod of x minus y, and then dx, and then the dy. Okay, now now we have to evaluate this both the integrals. So let us evaluate the inner integral first and then the outer integrals. So now note that, so the inner integral is over x, and then so we can write down the inner integral write down the integral as 0 to L mod x plus y dx as. So now note that here, whenever x is in between, when is x is bigger than y, then mod of x minus y is x minus y, and when x is less than y, then is the negative sign, the minus of x minus y, that is y minus x. So what does that mean? That means you can write down this as this 0 to y. So that means when x is in between 0 to y, so that means x is less than y. So in that case, this becomes y minus x dx plus the other case whenever x is bigger than y, so y to L. In this case, x is bigger than y, so mod of x minus y will be x minus y dx. Okay, so now you can easily find out the value. So what is the value of the first integral? Um, so you can easily find out. So this is y is, you can take the y outside is constant, so this is x, so y times yx minus x square by 2, and this is 0 to y plus x square by 2 minus xy, and here the limits are y to L. Okay. Now if you evaluate it, you can easily find out that when you evaluate the first limits, so this will be y square minus y square by 2, so this y square by 2, first term will be y square minus y square by 2, so y square by 2 and also you see for 0 this vanishes, so it's y square by 2, and the second one, when you evaluate it, x in between y to L, so it will be y square by 2 minus um, y square by 2 minus y square, so it is minus y square, and then the first evaluate for L, so for L it is L square by 2 minus Ly, so L square by 2 minus Ly you are getting here, and then minus for negative terms y square by 2 minus y square, so this is minus y square, so minus minus plus y square, so the final answer will be what will final answer? Y square minus plus L square divided by 2 and minus Ly. So this is the answer to this inner integral. Okay. Now we will find out the outer integral with the help of this inner integral. So then what will be the outer integral or the final answer? The final answer will be, so the expected values of this function capital X g of capital S capital Y, that will be what? 1 by L square and 0 to L, and the inner integral. So what was the inner integral? So it is y square plus L square by 2 minus Ly. So let me put it here, y square plus L square by 2 minus Ly dy into dy. Okay, so now you can easily find out this value also. So, and if you do this calculation, I think the calculation is simple, and the value will be nothing but, well, let me do it. So this L square and then you have y cube by 3 plus L square by 2 into y minus L by y square by 2, and then into evaluate the integral 0 to, okay. Now you see that this is 1 by, so you have L cube by 3 my plus L cube by 2 and then minus L cube by 2, and hence the result is L by 3. So what does that mean? That expected distance from the point of accident and the location of the ambulance is 1/3 of the length of that road. Okay, so this is one of the application or example where we can use this um, results of expected values for function of joint distributions. Okay, so now we can have some more properties. So when we describe another property, so maybe say property number 2. This is easy. So suppose in the you have random variable x and y, and you want to know that what is the expected values of x plus y. So suppose we have, so you know this function g of xy. This is just a special case of the results if x plus y, and then it is, you can easily find out that whatever x and y, which can random variable, whether it is continuous or discrete, doesn't matter, the expected values of these will be nothing but okay, I'm assuming that the both expected values of x and y is finite. So this provided both, so both these and this quantity, they are finite. Under this assumption. Okay, so obviously then one can easily find out that if we have more than 2 random variables, then this is just mathematical inductions. Suppose we have say x1 plus x2 in random variable. Then this is nothing but sum of the individual expectation of x1, expectation of x2, and so on, and expectation of xn. Okay, so these are simple observation one can easily find out. Okay, so now I'm going to define a few more uh, example with some more ideas, okay, before ending today's lecture. So so this is, we say sample mean. What is that? So what is sample mean? Now suppose I have in IITs, so let x1 extends is IITs. So I hope you remember what is IITs. IITs means independent and identically distributed random variables. Okay, and they have this, density function, or sorry, distribution function CDF. So the CDF of each of those things, they are IIDs, so they have the same CDF. If say if, then we define sample mean. So this collection of x1 x2 xn is called a sample of the distribution f, capital F. Then we define the sample mean by this quantity, sample mean by x bar. So this is what, this is defined by this quantity, summation over xi divided by n, and I is running over 1 to n. Okay, so this is called the sample mean of a distribution, whether when x1 x2 xn's are independent and identically distributed random variables. Now one can ask the question, what is the expected values of the sample mean? What is this? This is we can easily find out. So the formula already learned. So this is nothing but expected values of sum I equal to 1 to n xi and hence we know that constant you can take outside expectation. Constant you can take outside expectation, and then you can write down this as expectation of sum of xi equal to 1 to n, and which we can write down. We just learned that if you want to find out sum of expectations, and then you can easily find out this by these formulas. This is sum over expectation of xi. Now note that these xi's are IIDs. What does that mean? That means expectation of xi's are all equal. And let us say this is your say mu, expectation of say mu for FEI, because they are IIDs. Then you can write down that this is nothing but sum of n time mu, so n mu into 1 by mu, so the answer is mu. Okay, so the expected values of the sample mean is nothing but the expected values of the individuals random variables. Okay, so this is one important identity, and then you can also have many applications. So for example, you can have something called Boole's inequality. And this is all simple, so maybe just let me just tell you what is it. Boole's inequality. So what is Boole's inequality? Now suppose you have a1 a2 an, so let a1 a2 ends uh, they be n events, and we defined, so we define random variable this is called indicator random variable, indicator random variables for each I. So we define by xi. What is xi? So xi is either 1 whenever if ai occur and 0 otherwise. So what does that mean? That means x1 will take value 1 if the a1 occurs, and otherwise it is 0. Similarly, x2 will take value 1 if a2 occurs, otherwise it is 0. Okay, so this a1 a2 ends are events, and so now we denoting that capital X by sum of these indicator random variables x's 1 to n. So what does that mean? So this means that x denotes the number of events ai that occurs. Okay, so what does that mean? What is xi? So xi is counting, so this is counting function. So thus x denotes the number of the events ai occurs. Occur. Okay, so x is counting that how many events are occurring. Okay, now finally we will define another event, and this event we define by y. So define the event y if y is 1 if your capital X is at least 1. So at least one event occur out of these n events and 0 otherwise. So what does that mean? If neither of the events a1 a2 n occurs, then y will take value 0 otherwise. So what is y? So y is equal to 1 if at least one of those events ai occurs, otherwise. So what does that mean? So from the definition of x and y, you can easily find out that the random variables x is greater than equal to the random variable y. So what does that mean? That means that um, the number of events a1 a2 n occurs is always greater than equal to always greater than equal to this either 1 or 0. So it can be at least x can take at least one value, and I mean obviously it can take 0 also. So x in case 0 value, in that case y is also 0, or x can take value 1 to up to n, and that will be always bigger than y. So this is always this, and from this you can easily implies that expectation of x is always, obviously this is simple formula, is always greater than equal to expectation of y. Clear? So expectation of x is equal to theoretical expectation of y. But again you have the formula for expectation. What is that formula tells you? That tells you the expectation of x is nothing but expectation of sum over xi. Remember that x equal to sum over xi, which means that this is sum over expectation of xi equal to 1 to n, and expectation of xi is what? So each of the xi's will be either 1 or 0. So the what expectation is what? What expectation will be whether what is the probability that the event ai occurs. So what does that mean? That means this expectation of this will be probability that ai occurs, right? This is clear. So now let me make a note here also. The expectation of xi is nothing but probability of ai. Okay. Now so this is on the one hand you have this, on the other hand you know that the expectation of y. What is expectation of y? So this is nothing but that at least one of the event occur, right? Then only you'll have this. So expression of y is nothing but 1 times probability that y equal to 1 and plus 0 times probability is 0. So what does that mean? 1 time that means, so it is the probability that at least one of the events ai occur, and that is nothing but at least one of the events. So probability that union of ai equal to 1 to n. So this is the expectation of y. And then already we learned that expectation of x is greater than equal to expectation of y, and also you know individually the value of expectation of x and expectation of y. So combining these two formula, you see here this formula and these results. If you combine these two things, you will get that probability that union of ai equal to 1 to n, this is less than equal to so you note that sum over pi's. So this is sum over probability of ai's equal to 1 to n, and this inequality is called the Boole's inequality. This is called the Boole's inequality. So let me write down again the name, Boole's inequality. Okay, probably we have learned some new topic today, and maybe so there are plenty of other example. Obviously, if I have more time, I can give you more and more example. So maybe I can stop for today, and I will post this video to my YouTube channel, so you can get all the videos. So you can obviously um, click on bell icon so that you can get the notification whenever the new video is coming. That is for today's lectures, and you read from the home. Okay, and try to solve some of the problem from the book which I already mentioned in my last mail, and also reply if you have any question in the comment section so that I can address those questions also. So good luck.